In today's study session, we went over problem 14 in the practice problems part 2 for unit 1. And so we have an object. So the question says we have an object that is moving at a constant velocity. Okay, so here's our object, and it's moving at a constant velocity of negative 10 meters per second. Okay, so we know that the object we'll say is moving to the left if we call our positive direction to the right. When something happens at time equals 0, so we'll say that this is time equals 0 seconds, something happens to accelerate the object with a constant acceleration of 10 meters per second, and I do have a typo, that should be meters per second squared. I apologize for that. So our acceleration equals 10 meters per second squared. And the part A asks you to express the displacement of the object. Okay, so we wanted to express delta x, and initially that might be this direction, a delta x, or this direction, delta x, because it has a positive acceleration. So we want to figure out the displacement as a function of time after this t equals 0 seconds. Okay, just because this is how I drew the picture, well, if it has a negative velocity, it's gonna come this direction, right? It's gonna come to the left, then it's gonna slow down and stop, and then it's gonna start going to the right, okay, because of that positive acceleration. So let's just say that it's been a little while, and it's already on this side. So we're gonna set this as time t, and we wanna solve for delta x, the displacement of the object, as a function of time. Okay, so let's take a look at the equation. So we have these 4 equations we can look at. Well, the first one, equation 1 that we had, was velocity equals initial velocity plus acceleration times time. Well, nowhere does that one give us displacement, so that one's kind of out. Okay, this one, x equals x naught plus initial velocity times t plus 1/2 at squared. Okay, well, this looks like a little bit more what we want. So x minus x naught, if we subtract x naught from both sides, that gets rid of the x naught on the right side of our equation, and we can say that delta x, or the displacement, is equal to the initial velocity times time times 1/2 at squared. And what we've got, we know the initial velocity. Okay, we know the initial velocity, and we know the acceleration. Okay, so the only other thing on the right side of the equation here is time, which that's what we wanted. We wanted displacement as a function of time. So this actually looks like a great equation to go with. So let's go ahead and kind of plug in our numbers. Okay, so delta x, which is what we're trying to find, the displacement, equals, our v naught is negative 10, okay, times t, that's our time, plus 1/2, our acceleration is a positive 10 in the reference frame that we've set up, t squared. Okay, so delta x equals negative 10t plus 5t squared. So there we have come up with an equation that gives us the displacement as a function of time. And time appears twice on that side, but that's fine. It's still the only variable that we don't know over there is time. So we've done it. We've come up with an equation for the displacement as a function of time. Okay, part B of this question 14 is a little bit more involved. So B asks us to calculate the time. So we're looking for time when the displacement relative to t equals 0 is equal to 15 meters. Okay, so in our reference frame, we're now saying that we want to calculate the time when our displacement is 15 meters. Okay, so the good thing is we already have our equation. We've set up our equation right here. Okay, and we want to plug in for delta x. That's going to be the 15 that we plug in. So here's our equation. 15 equals negative 10t plus 5t squared. Okay, so this looks like something that we could use the quadratic formula for. or we could factor. And this question asks you to do it both ways. Okay, so let's start with the first way. It asks us to use the quadratic formula. So in order to use the quadratic formula, I need to rearrange this and set it equal to 0. So I'm going to subtract 15 from both sides. So I got negative 10t plus 5t squared minus 15. But that's not normally, oh, and that equals 0, right? That's not normally how I set up my, my quadratic equations. I want the 5t squared first, and then minus 10t minus 15 equals 0. Okay, so now this is in the form of at squared minus bt minus c, right? So in our quadratic formula, we have a, b, and c. In our quadratic formula, and you may have had to look this up, that's totally fine, but our quadratic formula tells us that t is going to equal negative b plus or minus the square root of b squared minus 4ac all over 2a. And it's coming back to haunt you, folks. we will be using quadratic formula a little bit in this class. So let me scroll on down here, and we can plug into our quadratic formula. So we got negative b, and b happens to be negative 10. So let's go, well, right, this would be like, if I was to write it out like in the general form, it would be plus. So our b is negative 10. So we got a positive 10, because we make it negative, plus or minus the square root of b squared, so that's 100. 10 squared is 100, minus 4 times a, which is 5, times c, which is negative 15. Okay, so, and then we have to remember to divide by 2 times a, which is 5. Okay, and that's what our t is going to equal. Okay, so we say t equals 10 plus or minus, this is going to be the square root of 400 all over 10. So we get t equals 10 plus or minus 20 over 10. So we get two values for t, which is kind of strange, right? But we'll talk about what it means. So we have two values for t. T can equal 10 plus 20 divided by 10, which equals 3 seconds, or 10 minus 20 divided by 10, which equals negative 1 second. Okay, the one we're going to choose is 3 seconds. Okay, and that's because it's talking about this object started out with a negative 10 meters per second velocity. So that means at some point in the past, it passed this 15 meters, right? And 1 second in the past, it passed there, and then it came here, and then it has a positive acceleration. Okay, so it's going to slow down in reverse directions, and then it's going to come back, and it's going to pass 15 meters again. So it passes 15 meters at negative 1 second, okay, and 3 seconds. But in this problem, it makes sense to answer with 3 seconds because we're talking about after that time t. Okay, so 3 seconds is what we get by using the quadratic formula. Okay, we could also come back to our original equation here. So we got, so this is now for part 2 where we're going to factor. We have 5t squared minus 10t minus 15, I think, yeah. Minus 15 equals 0. Okay, well, we can divide everything by 5. And we got t squared minus 2t minus 3 equals 0. And we actually could have divided everything. So this, we divided both sides by 3. Divide by 3, everything, right? And we could have done that here before we plugged it into the quadratic formula, but we didn't. You can get the correct answer either way. But, okay, so here is our equation. And let's factor this. So t and t, okay? And we want to think of, okay, what can we multiply together to get negative 3, but add together to get negative 2? Well, if I put a negative 3 here plus 1, when I multiply, I get -3, and when I add, I get -2. So that checks out. And this is equal to 0. So we can set each of these factors equal to 0, and we get t equals 3 seconds, or t equals -1 second, just like before. And same explanation that I gave you before, that's why you end up with two answers. And the one that makes sense and that we're going to give is the 3 seconds, because that's the positive time. So at 3 seconds is when that object is at 15 meters. And you can do it either way. And you can not always factor, it's not always easy to factor, but you can always plug it into the quadratic formula. Okay, hope that was helpful. And yeah, I hope you enjoyed. I'm sure you did.